We are back again. Welcome back, everybody. In the last video, I think that was a hard one. We did a lot of logic that's probably pretty new to you guys. And we don't need to use all of that logic all the time, but it's good to have in our toolbox because it's going to come up and we need to understand how the code actually flows when we start writing these statements. And you probably noticed in the last video, all of the code we wrote was basically just like in one big long file. And that's perfect when we're in the playground, when we're just learning how to code. But if we start actually building real apps, we would never just like throw all of our code in some file somewhere. Instead, we would actually create specific files that have functions that we can then call from our code. So what really happens when you run your app is you have one function that's going to run a chunk of code, and then that function will probably call another function that runs a chunk of code. And your whole app is basically a bunch of functions calling each other to run chunks of code. So instead of having one big file with all of our code, we're going to create a bunch of functions that will then run bits and pieces of code. And each function will basically have its own purpose. So you might have a function to do one thing, another function to do another thing, so you can keep your code separate. In this video, we're going to learn the syntax of how to actually write these functions. I don't think it is like overly difficult, but it's a lot of new syntax, and I think it deserves its own video. In the next couple of videos, we're going to write a bunch of functions. So don't worry about fully grasping it in this video. This is the intro, and then we're going to build on what we've learned. And we are back. What is up, everybody? We are rocking and rolling, getting through this course. I feel like the first couple videos are arguably the hardest just because you've never really written code before and there's probably a lot of new stuff to you. But as we get through this, I promise you you'll get more and more comfortable working in Swift. That said, in the last video, probably the hardest video, we did a lot of logic. This video is going to be significantly less. Let's call this maybe an easier video. But what we're going to talk about here is called functions. So far in this series, all we've done was write code inside this file. And one file runs again from top to bottom. So every line of code runs line 1, line 2, line 3, line 4, line 5. But that's not really how an app works when we actually start building an app. And an app really is just a sequence of functions that are inside files. So we're going to look at some of that now. Let's right-click the navigator, create a new playground page, and let's call this functions. All right, again, I'm going to leave the import foundation, and let's start writing some code. So firstly, again, we've been writing code sort of like this. Let my item of type bool equals false. Maybe it's a variable, and then we set my item equal to true. And then we maybe print out my item, okay? Now, this is fine for the playground, right? And this is how we write code. But in reality, this is not how an app works. An app works, your code is divided into functions inside each of these files. So like this file by itself, we would never be writing code just in the file. Instead, the file is going to have a series of objects and functions, and we're going to write logic inside those functions. And so instead of just writing code in this file, let's start putting code into functions. So the way we're going to do that, we're going to write func for function, and then we're going to give the function a name. So here I'm going to call this one my first function. And my first function, we're going to open and close the parentheses and then open the brackets. Now, again, this bracket is a closure just like we have in our if statements, but this closure will only execute when we call this function. Okay, so if I put a print statement here saying my first function called, and I run this code, it's never going to print because we're never actually calling this from our app yet. So this only executes when we call this function. And I will just copy and paste it down here. And this is how we call the function. So we literally would write my first function, open and close the parentheses. And this is now calling the code inside this function. So now that I have this here and I run it, it's going to obviously print out to the console. So this is generally how apps work. There is a initial function somewhere that the system creates. And then you're going to tell it, okay, when you start the app, first go to this file and show this on the screen. And then that file is going to call a whole bunch of other functions like load this data, show this button, all of these types of things. So your whole app is essentially a chain of functions that starts with one function. And so here we have like my first function. I'm going to create maybe another one called my second function. And so my second function called. And so now we could, in our app, we could call my first function, and then we can also call my second function. All right, so if I run this, obviously they both will run, but I could also start to chain these functions. So maybe when I execute my first function, I want my first function to then call my second function. So instead of putting this here, I will put this inside this code here. So what will happen now, this code is going to run line 1, line 2, line 3, but these aren't executed yet. And then it's going to get to here. It's going to call this function, which is this function and this closure. So this will execute. Then this will get called. This is calling this function, which will then execute this line of code. So if I run it, it looks the same, but now it's obviously slightly different. And we can continue this as well, right? So I can create another one. I can have my third function exit call, and we could have my second function then call my third function. And of course that will work. We're also not limited to calling one other function from this function. So I could put the call to my third function inside my first function as well, and that would obviously work. So the first thing to learn here is obviously the syntax of how to write a function, but we need to understand that we can basically chain functions and have functions call other functions, and that's a totally normal process in writing any sort of software. Now let's look at some more complex examples of functions. So down here, I'm going to create another function. And let's call this one maybe get user name. Open and close parentheses, open the brackets. And in here, let's say let maybe user name equals, we'll say Nick, that is my name. And then we will print user name. All right, so down here in my code, I will call get username. And obviously when this runs, it's going to run this closure and it will print it out, right? So let's print it out here. Now we're going to start to talk a little bit about access control in the coming videos. But what I want to point out here is that this constant of username is set up inside this closure. So if I'm not in that closure and I'm down here, I can't access this username. I can't say like let name equals username because it doesn't know what this is, because this is private to this closure. So in other words, if I had put this out here, so it was not private to this function, right? Now I can still call it in here and I can still access it here. But now this is public to basically everything in this file. Whereas if I put this inside this function, this data is now private to this closure. And again, generally in Swift and any programming language, we should make things as private as possible. So if I only need it in this function, then it's a good idea to put it inside the function. Now, of course, when we call get username, right now we're just printing it out. But what if when I called get username, I wanted to actually get the username back on this line of code? So I wanted line 26 to actually access the username so that I could then use it in my app. So really what I want to do is call this function and then return a value out of this function. And so the syntax for doing that is after we have the function declaration here, we can say, we use an arrow saying, meaning return, and then we give it a type. So what type of data do we want to return? Right now, again, in this playlist, we've already covered strings, booleans, integers. And this, of course, is of type string, right? So we want to return a string out of this function. And now the compiler knows that at the end of this closure, there should be a return statement that is going to return some string. So this is telling us right now it's missing the return because we're not returning a string out of the function. And so to fix that, we can just literally return the username. And I don't need to print this anymore, so I'm going to delete it. And now when we call get username, it's going to return us back the value, the string that is coming out of this function. So here, when I call this, it really should say let name, and we'll set it equal to the value that is being returned from get username. And if I hold the option button and click on name, I can see the name is of type string, meaning the value returned from this is returning us a string, which happens to be the exact same type as this variable constant that we have here now. So name is of type string. And again, this is type safe because this is Swift. So for example, if I said func check if user is premium, and it's a function that returns a Boolean, and maybe I just return false for now, I cannot set name equal to check if user is premium because this is returning us a Boolean, and this we are telling the compiler is a string. So again, Swift is type safe always, but here is even more important because it understands that the value being returned from this function needs to match the value that we are setting up in this constant. So I'll revert this back to get username. All right, let's do another example here, a little more complex. Let's create another example here. I'm just going to put a line in the code just to separate these examples. What we're going to do is maybe have a variable called user did complete onboarding of type bool, set it equal to false, and we'll do another one var user profile is created of type bool, set it equal to true. All right, maybe we have some function like check user status or something. And check user status maybe returns a Boolean if user did complete the onboarding and the user profile is created. Okay, so we could do something like if user did complete onboarding and user profile is created, return true. Say else, return false. All right, so just like in the last video, we had all of those operators that we learned about, right? Those ifs, those ands, those ors. All of that code we would basically be doing inside functions. So we can do that inside a function and then return the value that we were calculating. So here we can check the user status and it's going to return us true or false based on this data. But again, as I mentioned earlier, it's not very common that we're going to have variables just floating around the file in our application. You can technically have variables just in the code, but that's called a global variable and it's kind of frowned upon. So we generally won't have just variables in the file unless we're in a playground like this. So in a real app, this data would be in some sort of object or some sort of other function. So for example, if I had my data in this function, so let's say func maybe show first screen. Okay. And our code then calls show first screen. And then from show first screen, we want to then check user status. And if user status is true, we go to one screen. If user status is false, we go to a different screen. The problem we have right now in our code, though, is that the compiler inside this closure is looking for a reference called user did complete onboarding. And it doesn't know that this value is coming from inside this function. And this is how most code is going to be in apps. You're going to have code and you need to basically tell it where that data is coming from. And the way we do that in functions is to actually pass values into the function. So you're probably wondering why we have this little open and close parentheses here. So this is the initializer for the function. And we can pass data into the initializer that we can then use in the function. In like 4 or 5 videos, I'm going to start getting into initializers and like creating our own objects a little more. But for right now, I just want to show you guys that we can pass data into this function that we can then use. So if I wanted to pass a value for did complete onboarding, I put it right here. I will say, let's pass in a value of did complete onboarding of type bool. Let's also pass in a value for profile is created of type bool. All right, so now that we created both of these, we're saying anytime we call this function, we're going to also pass in a value called did complete onboarding and a value called profile is created. So when we're in this closure, we can now use these values. All right, so we changed the name slightly. I did it on purpose. So here I can put this, and here I can put this. So now check user status is understanding that we're going to pass in these values, and then based on these values, we're going to perform this logic. So when I come up here on my show first screen, I'm going to actually call check user status. And you'll notice that when I go to type it, the completion here literally shows us that we need to pass in a value for did complete onboarding and profile is created. The only way we can call this function now is if we pass in both of these values, which we will do here. We'll pass this in and we'll pass this in. All right, and now of course, check user status is returning a Boolean. So here we would say let status equals the result of this function. And so now in our code, we have this value, which is a Boolean, right? The status coming back, and we can do something. We can say if status is equal to true, let's just print out, show home screen. We'll say else print show onboarding screen. All right, so if I run my code now, we can see that show onboarding screen runs. So clearly status was not true. And that's because user did not complete onboarding. So I wanted to show you guys that we can pass in data from one function to another by updating the initializer. And again, these don't have to be Booleans. This can be any type. We can pass in strings, we can pass in numbers and integers, and we can even chain these. So if we had another function, func do something else, with maybe some value of type bool, right? I can chain these and I can call do something else and I can pass in a Boolean. Okay. Obviously, this is not part of the example, but this is how we pass data around the app. Basically, you have functions and then you send that data to the next function. So something that's really confusing when you're learning to code is like, how do I get the data from here to there? From one screen to the other. And it's not magic. I'm here to tell you that it is not magic. It is not some like weird thing that the computer is doing. You have to manually move the data around your app. And if the data is moving around your app, but you're not doing it, well, then it's probably some side effect of the code that you wrote that you're not actually understanding. So when we are writing code, we are always trying to manage what data is private to what functions and what files, and then how do we get that data from this file to that file to that file, and so on. So this is kind of just like an intro to functions. I'm going to comment this out. Let's come down here and let's do a couple more quick examples. So I showed you that we could do an if statement, right? But I want to look quickly at the control flow in some of these functions. So I'm going to create another line here just to separate out these examples. All right. And you'll notice here that this function returned a Boolean. This function has nothing here, meaning it doesn't return anything. So if I do a func, do something, and I don't return anything, that is the same thing as returning void. So sometimes you're going to see this word void come up when you're writing code, and void is just nothing. It's basically returning a function that doesn't do anything. It doesn't have a value. There's no true, there's no false, there's no string. It's just returning nothing. But in Swift, the compiler understands that if we don't include anything there, it's the same thing as returning void. So that's why I didn't have to write it here. Now, if I call do something, so I'm going to call do something, and we're going to print out execute 1. If I run this code, execute 1 will print out. But I showed you already that we can do if statements inside this code. So I can say if, let's create a variable here called maybe, I don't know, is new of type bool equals false. If is new, I'll run this code, and we'll say else, I'll run this code. So here I'll print new, here I'll print, let's print not new. I run this code, obviously it works. But I could also, since this code is not returning anything from the function, I could also just leave this off, and I can just say if is new, print this out, and it works. But if I tell this function that it has to return a string, okay, the compiler now knows that no matter what the logic is inside of here, every single case must return a string. So here I can return maybe the word new, but the compiler is still going to complain, because if it's not new and we get down to this part of the code, we're not returning any value out of the function. So the compiler knows that we are missing a return here, and that's what it's telling us. So here I would return false, and now it's going to work. And in the same way, and this is telling us that it's never going to be executed because obviously it knows that we're not changing the value of is new. So maybe if I had like our title of type string, put maybe Avengers, and we said if the title is equal to Avengers, let's return Marvel. And we'll say else, we'll say not Marvel. Okay. So now the control flow, this function knows that in every case, no matter what title is, it's either going to return this or it will return this. But if we got rid of this, there's now a case where nothing is going to return from the function, and that is not what we declared when we made this function. So once this is here, this is again Swift being type safe, saying that you said we're going to return a string, so you must be returning a string. Similarly, if we have the else statement here, we can return it here. And now the compiler actually understands that this if else covers every case in this file. So we actually don't even need to put any code here, because it knows it will return out of this function either here or here, and it will never get here because this will return. Another thing to point out here is that once you return out of the function, all of the following lines of code are not going to execute. So if I could write code here saying if title is equal to something else, and then I can have like a if statement down here, but the compiler again now recognizes that all of our cases are going to return out of the function here. This return means end this function and return value back to the rest of the app. So when I call do something, let new value equals the result of do something, as soon as we return a value, we're done with this function. Do something, this whole closure ends as soon as the return is hit. So if I return here, nothing I write down here will ever execute. And it's just going to bring the value back here and then continue with the rest of my application. So it's important to understand this return means return out of the function. All right, the next thing I want to point out is a guard statement. So I'm going to create another function here called do something else. I know, very clever names, right? So let's do another title here. And this time, instead of saying if the title is equal to Avengers, let's say make sure the title is Avengers. Okay, so we're going to use a guard statement for that. And so here we're saying, again, I'm going to say if title is equal to Avengers, then execute this code. Here we're going to say guard title is equal to Avengers, else. And then we'll have another statement down here, and we will return. Okay. And so this is now saying make sure title is equal to Avengers. All right. So if the title is equal to Avengers, we're going to say guard, making sure the title is equal to Avengers. And if it is true, we're going to come down here. Whereas if it is false, we're going to go into this closure. Okay. So here we would print out not Marvel. And here we would print out Marvel. All right. So slightly different logic, right? Whereas here it was, if this is true, enter this closure. Here we're saying make sure it's true so that we don't have to enter this closure, right? So if this is false, then we enter this closure. Whereas if this is false, then we enter this closure. These are two different ways to control the flow in a function. But again, this guard statement is returning us out of the function. So as soon as we hit this line of code and then we hit this line of code, we're going to get out of this function. So nothing after this line, once it runs, will ever execute. So if the title is not Avengers, this will run, this will return, and the rest of our function is never going to execute. All right, so up here, let's just do something else in our code. And let's run this, and we can see right now that Marvel is printing out because the title is Avengers, so we're printing that out here. If the title was something else, and I ran this, we're going to run into our else statement, and we should print out not Marvel. Okay? And just like the above functions, we can return a value out of this. So maybe we have this function is actually check if title is Avengers. And it returns us a Boolean. All right, so let's return this back to Avengers. So let's change this function. The title is Avengers, and we'll say guard, make sure the title is Avengers. If it is true, we will come down here. We will return true. If it is false, we're going to return false. Okay. Again, just to run it back, we're going to throw another function down here. Check if title is Avengers 2. And we're going to do our if statement. We're going to say if title is equal to Avengers, return true, else return false. All right, so this code and this code are doing the exact same thing, but one is using a guard statement. So a guard statement lets you check something, and if not, return out of the function early. And this is doing an if statement. So it's saying if this is true, enter this closure. Where here it's saying if this is true, come down here. If this is false, enter this closure. So guard and if statements are mostly used for the same thing, but the result is kind of the opposite, right? So if guard is false, we enter the closure. If is true, we enter the closure. And there are use cases for both of these in your app. These are both extremely common depending on what you're going to do. In the next video, we are going to get a ton of practice with these if and guard statements. So if this is confusing you right now, do not worry. We're going to go way in depth, in detail in the next video when we discuss optionals, because that's probably one of the most common places where we use these if and guard statements. But until then, just understand that when we create a function, the code in the function is private to that function. And then if we are returning out of the function, we must return that value in every version, every case of that function. And there's two main ways to control the flow of the function, and that's using if and guard statements. Great. The last and final thing that I want to leave you guys with is a calculated variable. And so this is you're probably not going to write an actual calculated variable for a while if you're following this playlist, but eventually you will start to use these more often. I would say they're more common in real apps, less common in like sample projects, but let's just discuss them really quickly because really what they are functions. So let's put down here calculated variables are functions, or we'll say are basically functions. So let's get an example going here. So I'm going to say let number 1, set it equal to 5. Let's say let number 2 equal to 8. All right, so maybe I have a function called calculate numbers, and it's a function that returns an integer, and it's going to return us the value of number 1 plus number 2. Okay, this works perfectly in our app. But as I mentioned to you guys earlier, it's not super common that we just have data here. So oftentimes we might write this function as calculate numbers, where we pass in number 1 of type integer and number 2 of type integer. And this will return us an int. And so in here, we will return number 1 plus number 2. And let's actually change the values of these. So this will be, let's just call this value 1 and then value 2. So when we are inside this closure, this will actually be value 1 and value 2 that we are adding. So we, of course, can call either of these and it works. So we can say let result 1 equals calculate numbers, right? So this one without passing anything in. We can say let result 2 equals calculate numbers. And then in this version, right, we can pass in number 1 and number 2. All right. But what I'm getting at is a calculated variable. So basically, if this function actually doesn't need anything to be passed into it, so here it does, but here it does not, we can actually make this a calculated variable instead of a function. And so I would literally make it a variable, just like we've been making variables all playlist. And we'll call this calculated number. And then we'll be of type integer and open the brackets. So in the same way, this is a function that returns an integer. This is a variable that is an integer. The difference here is that this number is going to calculate when we call it. So this closure is the same as basically this closure. So inside this calculated variable, I can do some calculation and I can return number 1 plus number 2. So this closure is literally the exact same as this closure. Anything that we would do inside a function, we can do basically inside a calculated variable. So really the difference here is that when we need to pass in values, which is most of the time, we will use a function so that we can pass in values. But if we don't need to actually pass in those values, then it's probably simpler to just make it a calculated variable. The thing that does trip some people up, though, is that this calculated number is going to execute this closure every time you call it. So it is just like calling a function. So this in our code or this in our code are basically doing the exact same thing. I just wanted to show this to you guys quick because you're going to see calculated variables in a bunch of the videos coming up and probably a lot of other online tutorials as well. So I'll put a final note here that let's put it up here. Calculated variables are basically functions. And let's just say these are generally good for when you don't need to pass data into the function. So this calculated variable, there is no way to pass in data. Like I can't do something like this. That's not how it works. If I don't need to pass anything in, I can get away with using a calculated variable. If I do need to pass something in, then I need to make it a function. All right. Now, of course, I can just have it as a function and not pass anything in as well. That is not bad programming. I just wanted to show you guys that there is another way to do it, which looks like this. All right. Again, a lot to take in, but I promise you, as we do this more and more, this stuff, it's going to become second nature to you guys. So even if this is confusing now, do not worry, do not stress out, because we're going to keep iterating on this code and eventually it's all going to make sense. I promise you. All right, so that is it for this video. We now covered functions, and this is exciting because as we start to build real apps, we're going to be basically chaining functions, and functions is how you actually start to build a real program. If we don't have functions, we really are limited with what we can do. So now we have functions, And we looked at some of the control flow in functions, right? We did if statements and we did guard statements. The next video, we're going to dive into optionals, which is one of the most important and powerful features of Swift. And after we learn what an optional is, we're going to then look at some more advanced control statements, again, diving into like guard and if statements. So if this stuff is confusing you guys, do not worry. The next video is going to have a ton of examples and real use cases for why we would use some of these statements. And I think by going over it again and again, it's going to really help you guys like ingrain this into your toolkit. Because when we actually start building apps, a full app is just a bunch of functions, a bunch of control statements, a bunch of logic for if, else, guard, and that's your entire application. So you guys are getting there. I know it's a lot to take in, but do not worry. The next bunch of videos are going to build on what we've learned. So we will really hammer down everything we've learned and continue expanding our knowledge base. The next couple of videos build on this logic, and the more we practice some of this stuff, the more ingrained and second nature that it will become. Thank you guys for watching. As always, my name is Nick. This is Swiftful Thinking, and I'll see you in the next video.